guys, this is Professor Janacek. I want to look at integration on products of trigonometric functions. This is a special type of U substitution. A lot of times people think this is a really difficult technique, and it can be very long and tedious, but it's really just a type of U substitution. If you can just remember that, it hopefully will make things a little bit easier. Now, when using this technique, we're looking for sine times cosine in the integrand or tangent times secant. Now, if we don't have one of those in the integrand, then we're going to use our trig identities and trig properties to possibly rewrite it into one of these. If that doesn't work, we might just have to use a different technique, but we need to start with one of these. Now, if we're looking at the sine times cosine, if the exponent on the sine is odd, our substitution will be u is equal to cosine x, and the differential will include sine of x. If the exponent on cosine is odd, then our substitution will be u is equal to sine of x, and the differential will now include cosine of x. If they're both even, then we're going to try to use a trigonometric formula. I like to start with the half angle formula. If that doesn't work, then I'll go to the double angle formula. And if you have either the case where the exponent on sine is odd or the exponent on cosine is odd, I do want you to know that in both those cases, we typically will end up using Pythagorean identity, some version of that. All right, well, let's dive in and take a look at an example. Let's try the integral of sine cubed x times the cosine raised to the negative 2 of x dx. Well, first thing I notice is that I'm looking at sine having an odd exponent, so we're going to be looking at that first case there. The thing to point out, the thing that I'll start with is that my differential will need to include a sign. So I'm going to start by taking out a sign and setting it aside with that dx. So I'm just going to write this as sine squared x cosine to the negative 2x, and that extra sign of x I put back here with the dx. That's going to be all part of the differential. All right, the next thing we have to do is, we're going to want to get to substituting cosine, which means all this other stuff here in the front has to be in terms of cosines. Again, make sure you understand the first thing I did was pull off that sign there in the back. The second thing I'm going to do is make sure everything else is in terms of cosines. Well, in this case, I do have a sine squared. How do I change sine squared to a cosine? Well, that's the Pythagorean identity. So sine squared is 1 minus cosine squared of x, and we still have cosine raised to the negative 2 of x, and sine x dx. Next thing I want to do is let's go ahead and take this cosine of the negative 2 and distribute it. So we get cosine to the negative 2 of x minus cosine squared x cosine to the negative 2 of x. And sine x dx there still in the back. Next thing, notice if I multiply cosine raised to the cosine raised to the positive 2 of x times cosine raised to the negative 2 of x, multiplying those just gives us a 1. Isn't that lovely? So this is cosine to the negative 2 of x minus 1 in there. All right, now it looks like my integrand, not including that differential, this is made up of two pieces, and I think they're going to most likely integrate two different ways, so let's rewrite this as two integrals. So really what you can think of this is I'm going to distribute this sine x dx to each of those, along with distributing the integral. So I've got the integral of cosine to the negative 2 of x sine x dx minus the integral of 1 sine x dx. I don't need to write that 1 in there. All right, now for this next one, I think it's going to be easier if I look at this as cosine of x raised to the negative 2 sine x dx. Yes, I could integrate this integral here at the back. I'm going to wait and do all the integration in one point. So here I'm looking at u being equal to the cosine of x. That's the substitution I want to make. If u is equal to the cosine of u, then what is du? Notice I'm differentiating here, not integrating. So if u is cosine x, then du is actually negative sine x dx. Oh, I need a negative in there. Well, let's go ahead and put that in. So this first part stays the same, but here in the differential, I need a negative sine x dx. Of course, I can't just go putting negatives in wherever I want them. If I want to balance this, I'm also going to need to multiply by a negative here in the front. This is the setup for u substitution. Notice if I multiply this negative and that negative together, they'll cancel and give me my previous step. This, again, is the setup for u substitution. All right, let's go ahead and write this integral in the back down so I don't forget it. Now, I think we're about ready to integrate. In this case, I'm integrating u to the negative 2, and then notice all of this back there, that's just du. So I'm integrating u to the negative 2 du. Well, what do we get when we integrate this? Notice now I'm integrating, not differentiating. Integrating this, we get u to the negative 1 over negative 1, or just negative 1 u to the negative 1. All right, so of course I don't really need that negative 1 there in the front. I'll just write that as negative u to the negative 1. All right, so in terms of our sines and cosines, we still have this negative out here in the front. This one here is still there. Just write that down. Then when we integrate, we have negative u to the negative 1. So we get negative u to the negative 1. Remember, u is cosine. U is cosine of x. So we have cosine of x to the negative 1. And that takes care of the first integral. Minus, now the last integral, the integral of sine x dx. Be careful, I'm integrating now. The integral of sine x dx is negative cosine x. Now, we've taken the integrals. Of course, these were both indefinite integrals, which means we need our arbitrary constant there in the back. Remember, if you integrate 0, you actually get that constant. Don't forget about that. And I think now we just need to clean this up a bit. Negative times negative gives us a positive in both cases. This first term, cosine of x raised to the negative 1, that's really 1 over cosine x. And so that means we end up with secant of x plus cosine of x plus c. Ta-da! There you go. Not so bad, I hope. Enjoy.